Welcome to Stemiverse podcast episode 39. In this episode, Peter and Marcus talk with Rich Lehrer. Rich divides his time between being the innovation coordinator at Brookwood School in Manchester by the Sea, Massachusetts, and working with educators both in the US and internationally to bring authentic project-based learning experiences to their students. For the past 5 years, Rich has been breaking ground in the use of 3D printing to connect students to their communities and world through finding and solving real-world problems. Over the course of his career, Rich has been an educator in the Canadian public school system, in international schools in Venezuela and Brazil, and in the US independent school system. Throughout his 27 years in education, Rich has been committed to the search for what works in education. His quest is to use project-based learning in the development and implementation of meaningful, engaging, and authentic student learning experiences for students. This is Stemiverse podcast episode 39. Stemiverse is a podcast produced by Tech Explorations. Our mission is to help educators become awesome at teaching STEM, be it at home or in the classroom. Whether you are a professional or casual teacher teaching in a classroom or a parent or caretaker teaching at home, this podcast brings you the knowledge and experiences of practitioners, academics, entrepreneurs, and lifelong learners who are passionate about education and strive every day to help our children prepare for life in a world of radical change and, why not, abundance.
This podcast is brought to you by Tech Explorations, a leading provider of educational resources for makers, STEM students and teachers. For a limited time only, go to texplore.com/Stemiverse and receive Peter's latest ebook, Maker Education Revolution, a book about how making is changing the way that people learn and teach in the 21st century.
Marcus, welcome. Great. It's nice and early here in Sydney, Australia. It's 8 a.m., right?
No, it's at 7:51. We are making great progress already.
And we're actually starting a bit early today because we are talking to Rich Lehrer, who is in the eastern part of the US, right, Rich? You are in correct. Boston, I believe. So what time is it over there?
So it is just before 5 o'clock p.m. on Tuesday afternoon.
Great. So actually, I like morning podcasts. My mind is clear. I haven't had to deal with bits and pieces happening during the day. So yeah. Okay, I'm not saying I'm going to do this again, but it depends when you've got special guests from the other side of the world.
Special guests make it very pleasant.
We'll do morning one. Yes, awesome. Hey, Richard. So I thank you for joining us.
Oh, my
really
pleasure.
Appreciate taking the time. And I'd like to start asking you to take a few minutes to tell us about yourself, your background. You can go as far back as you like, just to establish a bit of context about you. And then we're going to get into the things that I know that you're really passionate about.
Great. Thanks, Peter. Thanks, Marcus. It's great to be here with you both. Yeah, so I'm currently north of Boston. I teach in a small town called Manchester by the Sea. We're getting to be known internationally. There was a movie made by the same name as our town. So, and I'm about an hour north of Boston, as I mentioned. So I currently work at an independent school called Brookwood School. We're a pre-K to 8th grade school. I've been here this is my 11th year. Prior to that, I taught overseas. So I taught in Brazil for 5 years and Venezuela for 6 years before that. I taught in the international school system. Both of those were American schools that I taught at. So I was 11 years in South America. And then before that, I started my career teaching in the Canadian public system. So I'm Canadian by birth. I currently have dual citizenship, Canadian, US. And I started my career as a science teacher and did that for about 25 years with a few other things thrown in there, the odd French teaching, the odd bit of PE, the odd bit of service learning. But primarily my main focus was science and math. And the last couple of years, I've been branching off. I'm now out of the classroom as of 2 years ago. I had sort of the dream situation that a teacher runs into where some of the work that I was doing outside of my regular science teaching assignment, some of the work started to get some real traction and get noticed, and it seemed like people were interested in hearing more. So I resigned my position, and then Brookwood School wooed me back with a half-time position. So my current job at Brookwood is innovation coordinator. So I do that 60% of the time, and then the rest of my 40% of the time is just spent primarily consulting, speaking, writing, presenting about some of the authentic design work and project-based learning work that you were referencing earlier, Peter. So that's kind of me in a nutshell there.
Wow. So you've done a lot of traveling, really. I was reading in your bio that you also spent time in Rwanda, and something really interesting came out of that. I've got a question about that later on.
Yeah.
So you've been to Rwanda, Brazil, Venezuela. Did all that experience shape what would later come to be known as the authentic project-based learning and your philosophy in teaching and learning?
Oh, well, first, maybe you can tell us what is authentic-based project
I've got a special question about that.
Oh, I'm sorry. I'm ruining the flow already.
No, it's all right.
2 minutes in.
we got so much to cover. I'm prepared to get at it from any direction that seems to fit with you. So, yeah. So
I just wanted to drill the intentions before we get to the actual outcome.
Yeah, and in fact, you're right. My time overseas, and particularly my time in Rwanda, which I can speak a little bit more specifically about if you'd like to know more about that. But those things both laid the groundwork for my current work, but also there were some specific connections made through that work that really contributed to where I am right now, 7 years later. So definitely having a chance to do some teaching around the world, but also getting to learn from some incredible educators myself, that certainly has played a role in my current work. Yeah.
Marcus, clarify to my question about what is...
just before that, I wonder, so when you are a teacher from the US with that Canadian background going to a place like Brazil, for example, or Venezuela, I suppose you were appointed to those positions. And could you describe what it was like when you were there teaching kids at those schools?
Yeah, that's a great question. So those were both American international schools. So we taught an American curriculum to students from dozens and dozens of different nationalities. So in Venezuela, we would have probably about a quarter of our students were Venezuelan, and then the rest were from Latin America, Europe, North America. And so we essentially were preparing students for the IB course and AP, and really preparing those students for an American college experience, even though many of them didn't go to American colleges after that. So that was both the case in Venezuela and Brazil. Just for people who maybe don't know about the International Teaching Network, this is not a formal network. It's really a group of schools, hundreds of schools around the world that operate independently. And there are American international schools, British international schools, Canadian international schools, and each has a bit of a different flavor and a bit of a different mission. But they're loosely connected through that mission of trying to teach students of many different nationalities, some of whom are in the country for only a few months, and some of whom are in the country for their entire life. So really, really interesting for any educators that are looking to spice up their teaching practice a little bit. I originally took a 1-year leave of absence from my Canadian science teaching job, and after being in Venezuela for about 3 months, I wrote my district superintendent and said, I don't think I'll be coming back. I think I found my calling, and a 1-year intended stint turned into 11, and then I met my wife. She was not my wife then, but I met the woman that became my wife, and she was from the northeast of the U.S. And that's when she came back to do her doctorate. I came back with her, and that's what landed me here in the U.S. I came on an H-1B visa, and then I got my green card, and now I have my citizenship, and we have two kids who have dual citizenship as well. So.
Right. So that's very interesting. So at that point, were you involved in what we now call STEM education and project-based learning, or were those ideas still becoming or being formulated in your mind and your methods?
Yeah, so when I look back on, I'm in my 29th year at education, so I have an interesting multi-year perspective on teaching. I started teaching in very similar ways that I had been taught myself, not particularly relevant topics, not a lot of effort made to make the learning meaningful to students. You know, a lot of kind of canned science labs and math worksheets. And so really that idea of relevant, meaningful science work, and even the idea of combining science and tech and engineering math, those things were not really on my radar, and certainly were not being stressed when I was being trained as a teacher. However, when I look back, I realize one of the reasons I got into teaching, and specifically into teaching STEM, was because I felt that I had been shortchanged a little bit in my own education. Apologies if there are any of my former teachers out there listening. But I
feel the same, by the way.
But I felt that piece that was missing for me, that, making the learning real and connecting it to real life things that I cared about, that became something that I intended to do, and I strove to do that. So in fact, looking back now in my first even 5 or 6 years of teaching, I see elements of what we now call project-based learning, just because that felt like the right thing to be doing with kids. Longer term projects in which students have a chance to own some of the inquiry and the research, and then at the end of it having some public product that they apply their learning, and I see pieces of that, and that I just continued to develop as I kind of moved through my own career, to the point where all of a sudden I realized, there's this movement out there called project-based learning that is 100% in sync with what I think I would have liked as a student, and what I see resonating with my own kids, and so now we do that.
I was reading one of the articles that you've got linked on your website, which we'll include in our show notes as well, that there was a student Gallup poll back in 2016 that found that 42% of students in grades 5 to 12 aspire to create, and emphasis in create, something that makes a world a better place.
Yeah.
So hence my end, I can see your optimism about the future. So can you tell us a little bit about that, and what does that say about today's children, like the next generation growing up? And I think that can actually lead us finally to authentic project-based learning experiences.
You've really effectively buried this lead. I love it. It's great. You know what, Peter, I think you've absolutely hit it on the head there. I am on a daily basis absolutely blown away by what kids are capable of doing, what problems kids can solve. When I was younger, I used to see children and students as just sort of lesser versions of adults, and I absolutely no longer see that. I have seen too many examples of kids, create things and solve problems and throw themselves into making the world a better place that would just absolutely blow any adult's version of that away. And so my own thinking on just the role of young people in society has changed really dramatically, even in the last 5 and 10 years. And I got to tell you, that is absolutely what gives me hope. I see it in my own kids. I see it in the students that I teach. I see it in the students of teachers that I train and work with. And yeah, as I said, all is not lost. There's an incredible generation just waiting to take the reins on this. And in fact, they're not even waiting any longer. I don't know if you followed this, the reaction to the school shooting in Florida that just happened recently,
yeah.
and the students' reaction to not just be passive bystanders, but actually take the reins on this thing and try to move, legislation in a place where public opinion couldn't do it. So there's something really powerful there. And in fact, I think that even that situation relates to some of the things that we'll talk about the empowerment of kids. So anxious to get into that topic. So,
would you say that student activism is a new thing, or is it something that's always been happening?
Yeah, I don't think so. I think what the new thing is the power of the tech that kids have access to now. And a student with an effective piece of writing can reach 1 billion people, and that's something that when I started teaching, that was just absolutely not possible. And I've selected one form of tech, the internet and computers, but kids have access to the most incredibly sophisticated technology right now with the potential to make really effective end products and to broadcast them and share them with millions of people. And that's a game changer as far as I'm concerned in education. All of a sudden you have kids who can create on par with adults. And not only that, but they have fresh ideas and they have enthusiasm and they have the time to throw at it. And they also are naive enough to think that they can change the world, which I think actually many of them can. Yeah.
Yes.
And I think finally, that spirit and just absolute like fire in the belly that kids have always had. All of a sudden now they have the reach and the ability to package that into like high quality, sophisticated products. And that's, certainly that Florida story that I referenced, that's part of it. The work that we've been doing with kids doing 3D printing and creating original inventions and then being able to share that with millions of people, like it's happening across the board. And what I think is happening is, and we'll certainly get into this, but those sorts of tech pieces that allow kids to do those really sophisticated solutions to problems, then that's all of a sudden changing the way I think kids see themselves and how we see them. And all of a sudden we're seeing student empowerment that has nothing to do with technology, but they see the way being led by the students who have harnessed those pieces of tech. So,
yeah, power to the children.
Yeah, you got it.
I was looking at I know that your email address. Do you mind if we give it out to people?
Yeah, not at all.
Because I think the name of your email address is quite revealing about how you think about things. So your email address is creatingchangemakers@gmail.com.
Yeah.
So is that how you see yourself? You help. You see children as change makers. Even current, like many children, don't have to wait for tomorrow to make their impact in the world. They're doing it right now. So are you a facilitator of that?
You nailed it right there. Absolutely. When I used to teach science, I used to think that my job was to get as much content understanding into kids' heads as possible. And in fact, early in my career, that was the case. And then the internet came along and threatened to make me obsolete. And then what I realized was, kids are going to be able to access information at the click. Well, not all kids, obviously, because not all kids have access to that high quality tech.
Sure.
But for a lot of kids on Earth, they can. There's no reason to memorize the periodic table right now because kids can click a button and hit, 100,000 periodic tables at the click of a button, and all of them more current than the one that's in the textbook to my right here. So all of a sudden I realized like my job, yeah. And all of a sudden I realized my job was not to do that content transfer, was much more to help students understand what to do with that content. And that's been a long path to get to that point where all of a sudden viewing something like math and science and tech as tools to make the world a better place, to positively impact their own lives, their communities, their world. That's the true job, I think, of a STEM teacher. So, yeah, that's where I am with creating Changemakers.
Awesome.
So, I guess I have to ask the question.
Do it, Marcus. Do it now.
What is an authentic project?
Yeah, so
aesthetic design. I like the word design in that.
So there are there's a number of different definitions for project-based learning out there. So I consult for an organization called the Buck Institute for Education. And if anything about what I'm saying resonates with anybody, you would likely want to check out BIE.org. And the Buck Institute for Education has been promoting project-based learning for about 25 years. And we're now certainly in the US, we're the premier organization for training teachers to do that. So we have 100 what are called national faculty members, of which I'm one. And we all deliver workshops to teachers on how to do this. And essentially what it is, it's not a new way of teaching. It is really just a recognition of the things that excellent teachers have been doing in the past. It's an effort to make learning meaningful and relevant. Students work over a long period of time. And at the bottom of everything, it's a method to teach content, skills, dispositions, learning, understanding. And so it's not, a lot of times people mistake it for, this is just sort of fun time, or this is, give students kind of free time to really explore their passion. That's not, at least BIE's definition of project-based learning. It is truly a way to teach students rigorous content, understanding dispositions through the context of projects. And really, if you think about it, that's really what adults do. In fact, you're doing a project right now with this webcast and all of the podcasts that you do. Lawyers and teachers and filmmakers, they do projects. They're long-term periods of study where they have to learn specific skills and content to be able to accomplish that. And what we're really trying to do is take that thing that actually happens in the world of work with adults and just do that with students as well. So there's a couple of other hallmarks of project-based learning. Usually at the end, there's a final product that students will then present to a public audience. the inquiry is passed to students. So again, it's not just sort of dumping the content into the kid's head, but teaching them how to find good resources and sift through them to get the understanding themselves. So I'm happy to talk lots more about project-based learning. The authentic part of it is obviously, that's my passion right there. And so I use the word authentic to just apply to anything that is connected to the real world, whether it's through the topics that students are studying or the tools they use or the way that they finally present their final project. Authentic in that it would parallel the work that adults do, but it is a much more sort of novice version of that. So I'm happy to go into more detail if you want me to clarify any of those points there. So.
Yeah, definitely. So there's a distinction, I suppose, that you're making between normal, widely accepted definition of project-based learning, which emphasizes obviously projects and learning through a project, leading a lead. There's a goal that you want to achieve, and typically it's a long-term project. It's not like a single, classroom session project. And then you have the authentic project-based learning. In a nutshell, what's the main difference between these two?
Yeah, great question. So really, and you may get a number of different definitions on how, depending on who you're speaking to. But for me, it has to do with the impact. And for me, an authentic project-based learning would be one in the end where students have made a difference. And they've made a difference in a way that resembles the ways in which accomplished adults and young people have been making a difference, oftentimes just on their own. But in this way, we're actually using it as a chance to embed content with that. And I actually had this little epiphany, actually only a few months ago, but I realized, school has been pretty authentic for a number of years. It hasn't always felt that way, but when I went to school, I learned grammar and math skills and science, and those are very authentic skills. But the timeline on those, I was learning them when I was 11, and the idea was, maybe when I'm 30, I might have a job that will allow me to put these things into practice. And that's something that in the PBL world we call just in case learning. You learn something just in case you might need it. And what I realized, like authentic project-based learning, like shortens that timeline. And we're not going to wait 25 years to allow a student to put into practice the thing that they've learned. They're going to do it right now. And if you can shorten that timeline down to a couple of months, you have some students who could not only learn the content and the skills, but then actually use them to affect positive change in their life or their school or their community or their world. And then you've got that when that actually happens, that is an incredibly powerful situation. Maybe, do you mind if I share, this isn't one of my projects, but this is a project that a teacher that I was working with, she was in one of my workshops. She had this idea for a fractions project. And she wanted a project that would show kids, not only like get them to learn fractions, not in that sort of just in case they'll need them, but learn them just in time to do this project. And so she taught her students how to, this is a 6th grade here, that would be 11-year-olds. And she taught them fractions. And then with that knowledge, she had the students make jars of cookie mix. And they were going to sell these and hopefully raise a little bit of money for a worthwhile charity. And they realized that one of their fellow students in their school was in need of medical research. She was born with a genetic condition, and they had set up a cost of $1 million for the initial tests for the research. So they thought, well, we can maybe sell these jars of cookie mix, put a QR code on the jar, and then anybody with a reader could see the math behind it and see what they were doing. And they began by selling about $3,000 worth of those. And they realized that all of a sudden they had just started something big. And so they made more and they sold more. And by the end of it, they had raised about $50,000 towards the health of, or the research for one of their classmates. And that kicked off some really interesting interest in that project. So a local news station got a hold of it. And then some professional football players heard about it and they tweeted it out. And at the end, that project raised over $1 million for the girl. It's from Ipswich, Massachusetts, if anybody wants to research. And just this idea that these kids took this like thing that we all learn, right? How to do fractions, but they didn't learn how to do them. They didn't do it in a way that they were being, kind of lorded over by their teacher and forced to do it and just do worksheet after worksheet. They saw that it was this important tool that they needed to use to create these products that they were then going to use to help one of their classmates. And when we talk about shortening the timeline to make that a really authentic problem, like now those kids, whenever they think of fractions for the rest of their life, they're going to see it as this beautiful, skill or tool that not only helped one of their classmates, but really empowered them to be able to not only feel like they could make a difference, but actually really make a difference. So.
Wow, yeah. So that is definitely a very impactful outcome for a project, right? So the way that after your description, the way that I think about the differences between authentic project-based learning and just vanilla, I call that project-based learning, is that both have got outcomes, right? The difference is that the project-based learning, the outcome is something like, I'm going to build this robot and I'm going to learn X, Y, Z in the process. Where with authentic project-based learning is sort of the above plus. And I also helped a child with a disability to get an artificial hand so that radically improves his life,
That's
right?
Exactly right. Yeah. Yeah.
Marcus?
So to steal your vanilla word, I was going to say detractors of PBL often say that it lacks the rigor of vanilla teaching.
Right. Yeah.
How do you add rigor to PBL?
Yeah, so that's the true both the challenge, but also the incredible reward of doing this work. That oftentimes teachers are not put in the position of having to think of, what are the real life applications of these things that I'm teaching? And it is possible to try to fill a kid's head with a lot of things that just don't have meaning and don't have actual application. And so what project-based learning does is puts the teacher in the position of asking the question, like, when is somebody really going to use this? And can students do that in their youth or their school years? And that idea of adding rigor supposes that projects in themselves are not rigorous. And in fact, if you think just think of some of the projects that colleagues of yours might do, whether it's starting a business or doing a presentation or preparing a legal case or designing a building or anything that adults do, they learn rigorous content by doing that. And so if you can find projects for kids where the content that they're going to need to know is content that would be taught anyway. And that's the key thing here, is that nothing about this model of project-based learning says that anybody has to do anything different aside from showing kids that there's an actual application to the material that they're learning. So I can give you a fairly straightforward. This is actually one of the first, what we call it PBL here. So that was one of the first. This is one of the first PBL projects that I did. So when I was first started teaching in my third year of teaching, I was teaching on the west coast of Canada, and Fisheries Canada started a project called Salmonids in the Classroom. And what it did was Fisheries Canada would give you a cold water aquarium, and they would donate, probably 5,000 fertilized salmon eggs, and then you would raise those in your school. And any of the fry that survived, you would then work with the hatchery to actually release those fry. And in addition to raising the eggs from eggs to fry to smolt and then releasing them, we also then taught students, the life cycle of salmon, and we taught them about environmental factors that could affect river quality, and we talked to them about food webs and all of those things that when I was taught them, I was taught, read this chapter in a textbook and then answer these worksheets about it. And maybe if you're lucky, you could do a presentation where you would read from an encyclopedia to your classmates. And what this is much different. Like, it was the exact same content, but it was being learned in order to understand this thing that the students were going to do that would have impact on their community, their environment and their community. And that was really my first experience with project-based learning proper then. And in fact, that wasn't really, we didn't call it project-based learning at that time. I just saw that and I thought, oh my God, that is something I want to be involved in, like giving students who actually will become fishermen and will become potential business owners and industrial employees around this area. Like, I want them to have seen the life cycle of the salmon from egg to adult, and what better way to do that than to have them raising that in their classroom and then releasing the fish when they were mature. So
yeah, nothing really beats reality when it comes to learning, right? Like a textbook is nice, especially it's got color pictures, but seeing the actual thing developing in front of your eyes It's a whole different thing.
Yeah, and that question, I didn't mean to. I hope I didn't come across as being, overly harsh on that question about rigor. That's the number one question that we get before we go into a district or a school, and really just to let educators and administrators know that project-based learning is not new. It's just that there was just a small sliver of teachers that were able to connect that rigorous content to actual school learning. What we're trying to do is just broaden that base and have many, many more teachers be able to help students see the real-life applications of the content that they're learning.
I think when people talk about rigor in educational outcomes, they are really talking about tests and the ability to test the students to make sure that they've achieved certain outcomes.
Or meet the syllabus.
Really. Yeah, meeting the syllabus, so then you can test it. So do you think that testing and project-based learning, PBL, is compatible with each other? So, for example, if we have a school, let's say a hypothetical school where all learning happens in projects, and then time comes for college or university where you have, at least at this point in time, still mostly it's an exam-based system to gain entry. Would those same students be able to deal with the exam system after having exclusively PBL style education?
Yeah, that's a great question. So there are about 5 different approaches that I could take to answer that. The first one is that this could be different around the world, but certainly here in the U.S., there's an increasing recognition on the part of colleges that just to have students coming in with book learning is not serving them especially well in colleges. So in fact, one of the colleges that was key to kind of the work that I got in right now is MIT, so the Massachusetts Institute of Technology. So one of the top engineering colleges in the world, and I became connected to a part of their college called D-Lab. And if anybody out there wants to see what the power of students to create authentic solutions is, please Google MIT D-Lab, and you're going to see it there. So when I found out that I was going to Rwanda, so I went to Rwanda almost 7 years ago to study the role of STEM.
2011.
Yep, that's right. So I was there to look at the role of STEM and STEM education in helping Rwanda recover from the genocide. So I had a chance to visit a number of different schools and see what was happening, see how Rwanda was embracing STEM as a route to rebuild their country. And so I was very superficially aware of some of the things that MIT's D-Lab were doing. And so I contacted them. I just said, I'm looking for curriculum or examples of schools where students are doing very similar things to what your engineering students are doing, which is creating actual authentic solutions to problems that communities can implement. And when I mentioned that to them, they said, well, we don't really have any schools that we're working with, but we've been very passionate about this and we would love to work with you. And so what happened there was we then began to collaborate and create projects for middle school and high school students where they use STEM projects to create real solutions, but also then to connect with colleagues and peers around the world. And that is project-based learning, at its core. And many of the top engineering universities from here in the U.S., from MIT to Olin College to Purdue, they have project-based learning engineering courses. And so certainly, the STEM colleges are leading the way, but other colleges are seeing that as well, that having students coming in, just being able to be good test writers and play the game of school, that is only getting them so far in terms of being able to be successful in kind of the new. And in fact, there's a real movement here in the U.S. The college boards, that's just the way that high schools communicate, students' abilities and skills. There's a real movement here to completely revamp that system. It's called the Mastery Transcript Consortium, and it's a group of some of the top high schools in the U.S. that are banding together to change the way that we inform colleges what kids can and can't do. And so there's this multi-pronged almost revolution that's starting that project-based learning certainly plays a role in. And just the second thing I wanted to mention was that there is a real place for traditional learning within project-based learning. There's a place for direct instruction in a project-based learning project. It's just that shouldn't be the only thing that happens. So there's about 3 or 4 other answers to that question that I would love to share as well. Another show.
Definitely. Yeah, we're going to need another hour for that. I'm just thinking that, like for me, testing is, because personally I had so much problems with standardized tests, exams, and all that. It's so last century, maybe century before last, actually. And I think the recipe needs to change. As you said, it's not that we don't want to do any tests of any kind at all. It's just that the mix has to change of how we assess student capability, and then we use those tools in order to assist students to, plug in any knowledge gaps, for example, especially if we are teaching with goal to mastery, not just superficial learning good enough for a test, which is the goal in many circumstances as well in schools, right?
Yeah, we often
teach for the test.
We often think about it as just for schools, but I was thinking about my time at university. When I was doing engineering, it was always test, test.
My life has been one test after the other.
But postgraduate was all PBL.
Right.
I love postgraduate.
So it was like, actually, we should do everything like this.
That's why it took me so long to do all these postgraduate degrees.
Yeah.
Because I loved it so much.
Yeah, it was fun actually building stuff.
Yeah, and actually, maybe I can give you an example. So, sometimes all that is needed is a bit of an adventurous teacher or a teacher that is not risk adverse to sort of lead a school in that direction. So, I think one of the projects that I've been deeply involved in for the last 4 or 5 years has been the 3D printed prosthetic work that we've been doing. When I first proposed that to my administrator, so the school that I teach at, Brookwood, an amazing school, but we also are tasked with preparing our students for a very rigorous high school experience. And when I proposed to my administrator that I wanted I had come across this video where these two designers had created the first 3D printable prosthetic, sort of a do-it-yourself prosthetic. And when I saw that YouTube video, I got very excited because my son was born with a condition called symbrachydactyly, where the fingers didn't grow on his right hand properly. And when I saw that idea that, there might be a way not only for me to build a prosthetic, but maybe I could get a group of students to do this. When I proposed that to my administrator, it was full on brakes. It was like, that sounds a little bit risky. And, we would be worried about the health of your son, and we'd be worried about the disappointment if it doesn't work out.
What do they think you're doing?
Yeah, and so I said, well, okay, that sounds great. We won't pursue it. And sort of a little bit kind of behind the scenes and things like that, I created a 3D printing club, even though we didn't have a 3D printer, and I just used that as the moniker. And then we went ahead and we took 6 months and we built Max, a functional prosthetic. And
it's like skunk works, right?
Yeah,
that's right.
But before we go too far down this route, could you please tell us how you created a 3D printing club without a 3D printer? You think there's a lot of schools out there that don't have the resources to buy a 3D printer.
And without your administrator really being in the loop.
Yeah.
Yes.
So what we did, so I found 12 students who would be part of my nefarious campaign, and from the start, it was clear to them that we were going to be trying to build this prosthetic, and there were 3 things that were needed. We needed some thermoplastic sort of splinting material. We needed metal hardware, and then we needed 3D printed customized pieces. So we just, I worked with them. I wasn't really their teacher. I was just one of the group members, and we split into 3 groups. One group to find the metal hardware, one group to find somebody who could get us some thermoplastic, and one group to track down somebody who had a 3D printer. When I first did this project, I actually thought 3D printers were subtractive and that they actually carved away. And I remember that when I actually went to a school that was about an hour down the road from us that had just bought a brand new MakerBot. And when I saw that it was actually additive, I remember being like, oh my God, I didn't even know, that this didn't have any concept of how it works. So we used that school. It was a high school, even though we were an 8th grade club. We paired up with them because they were interested in having an authentic use for their 3D printers. So they created the pieces for us, and we built the prosthetic using the pieces that they had created and the pieces that our maintenance department, the metal hardware they had found, and then Boston Children's Hospital made a donation of some of the plastic. So we had the materials, and the kids asked if they could come in for a couple of weekends and work on this thing, and then we finally had the functional thing, and we brought Max in, and I got to tell you, when I put that thing on his hand, and he used it to pick up these blocks with his right hand. That was I say that's the 10 seconds that changed my life right there, because all of a sudden these ideas that I had that kids could make a difference, and this new generation of technology that was allowing kids to create these hyper effective solutions, all of a sudden there it was like impacting my son and my life directly. And we happened to catch a little video of the first time that he started to pick up some blocks with that, and that's been the kind of little calling card that we've used, and that single project has now led to I've got about 20 different authentic design strands on the go that I trace right back to that original project that we did. So.
Yeah, I saw the video.
Cool.
We are going to link it to our show notes as well. And you can see how Max is trying out his new hand for the first time with trying to pick up a yellow object. I think so. It looks like a rectangular block. And how happy he is when he finally makes it and he can pick up that object through his index and thumb and picks it up.
Are there any electronics within the prosthetic?
No, so these are all mechanical prosthetics. They have elastic bungees that keep the hand open and splayed, and then there are cords that are tied to the bottoms of the tips of the finger, and they're anchored at the back. So when he bends his wrist down, it effectively pulls the tips of the fingers in towards the palm, and so he can open and close the device by bending his wrists. So not electronic.
So it's totally customized for what Max can do, the parts of his hand that he can control in order to control the prosthetic hand.
Yeah, that's right. And in fact, we've even moved away from those kind of 5-fingered hands. And after a couple of years of building those hands, and this is the work of an incredible organization called Enable. So they're leading the charge on the global charge on 3D printable prosthetics. You should check them out. It's E-Enable. But we've realized that Max, those 5-fingered hands, they're great from a social emotional point of view. And when he comes into his school, instead of being, the little boy with kind of a crazy hand, he wears this like bright green, Incredible Hulk prosthetic, and 30 kids will flock to him and they want to see what it is. And it just gives him a tool to kind of message for his classmates who he is. But what we're really realizing that what he needs is like a hyper customized device that is purely just based on functionality. So in fact, we've moved away from those articulated fingers and mechanical. And what we're doing now is we're just taking scans of Max's hand and importing them into Tinkercad, which is a really simple design program. And then we actually are making these devices that are perfectly customized to his hand, because it's his actual a 3D scan of his hand that creates the negative space that it goes into. And then we pass the designing of the sort of business end of the prosthetic to the students. So they would look at their physical education program and what sorts of, sticks or PE tools would Max not be able to use, and then they can create a piece that slides into the device. Or they go into the music department and they take a look like what sorts of bows or mallets or drumsticks could he not hold with his hand, and then they design the piece that then slides into the customized device that we have. So we're now just all about like customization. Works perfectly for him, not a universal solution, but why not have every kid who has what's called an upper limb difference? Why not every kid should have a scan of their hand that they could then use to work with engineering students or just like regular kids like the ones I work with, and create devices, through the community like that. So.
That's totally impactful.
Has Autodesk reached out to you? Surely they've got to love this.
Yeah, they do. Yeah, so I do a fair amount of work with Tinkercad now. So there are, and in fact, it's kind of crazy. Like the prosthetic work has become kind of now the side work. Really, the majority of work that now consumes my time. So after we built those prosthetics, and I thought, oh yeah, what we need are these like engineered pieces that go on the hand. Then all of a sudden I realized, oh, every one of our students should have that ability to be able to find something in their community where a 3D designed and 3D printed solution could be needed. So we created this thing called the Problem Bank. So I had this idea in a shower one day that just like, oh, we could like solicit problems from our community, and they could send them in and we could post them on a website. And then any student in our community could see the problems posted there in a class or in a study hall or in an after-school class or on their own at home. which actually has turned out to be the majority of times that kids work on these projects is just on their own. So what we did is we just have this repository of problems. We routinely kind of do calls for problems from our school community, and we post them on this website, and then students just design the solutions, and we keep it in-house so that the students can actually see their designs being implemented and get a chance to go through that iterative process. And so that caught Autodesk's eye. So I shared that with Tinkercad, and they got really excited. And then we actually took that same idea. We had been doing that work in-house in our school community, and we realized, there might be other community groups where our kids could be designing those solutions to real authentic problems. So we connected with a seniors housing organization on the North Shore called Harbor Light Community Partners. So we now are in the third year of these middle school senior design collaboratives where our kids go and they develop relationships with the seniors. And then after several meetings, they turn the conversation towards, what sorts of, here's what 3D printing is, what sorts of problems might you have seen in your life or the lives of the other people who live in this residence, or just seniors in general. And then our students work with seniors to begin prototyping solutions. They use Play-Doh and cardboard, and then our kids teach the seniors Tinkercad, and then they co-design them. And then our students do sort of the final piece where they create versions of the devices, and then they refine them and then finally share them with the seniors. And those things, certainly the prosthetics, that caught Autodesk's eye, but the problem bank and now the senior problem design collaborative work that also. So I just did a big webinar for Tinkercad just on this idea of using 3D printing as a route towards getting kids involved in community. I hesitate sometimes to use the word service just because that idea of service it feels like a loaded term. It's much more collaborative, having kids work with people in their communities to find problems and ideate solutions and then actually create the solutions. So
there's no age limit to project-based learning.
Yeah.
The seniors collaborate with much younger project members to create solutions for senior problems. And I'm looking at the website where you list a lot of those problems. Now it's designproblembank.weebly.com. I just want to read out one problem so that our listeners get an instant idea of what these problems look like. And so here's one. Hi, we are looking for PVC joiners to allow us to have our kindergarten students create structures out of PVC. Could you design some of those for us? Thanks, Mr. P. So a problem like that will arrive to the website. Somebody will post it there. And what happens? What's the next step?
Yeah, that's actually it's very interesting that you chose that one, because that project itself created a whole kind of new suite of approaches to the work that we're doing. So before that project that problem was posted, essentially a student would take on the project. They would do some initial prototypes. They would actually walk down the hall to the teacher. They would share the prototypes, get some feedback, go back. We would do what we call a digital prototype, where they would just do a Tinkercad mock-up of it, share the screenshot of that with them, get some feedback on that. We created an approach that we call the design slice, where rather than having students take 12 hours to print off something that likely is not going to fit, we get them to just think, what is the absolute lowest profile that you could create? Rather than printing that 15 centimeter block off, why not just print a 1 millimeter profile of it and then use that to check to see if it works. Once they've gone through, and that way that's a 10-minute print, so they can go through like 4 or 5 of those to refine the specs of it. And once they've done that, then they'll extrude it up and they'll create the whole thing and share it and continue to get feedback. Before that project, we had students going from problem, idea, first solution, iterations, final solutions. They were going start to finish in that process. And what we realized when that project was posted, we realized, this does not have to be something where kids are going from the problem all the way to the final solution themselves. And so what we did was we created a team between kindergarten students who are going to be the final users of it, 5th grade students, those are 10-year-olds, and myself and another teacher who had some design skills. So what we realized is, the 5th graders that we were going to do that project with, so we did it as part of their science class. They didn't have the Tinkercad skills to be able to create the actual joiner themselves. And in fact, the ones that we tried just snapped every time we tried to use them. But what we realized was we could use something different. We could use wooden dowels that are much lighter. And so we had the fifth graders prototype them in Play-Doh, determine which angles were needed, how many different pieces had to come together at a corner. And then they designed a very basic version of it. And then the other teacher and myself, we used sort of a dovetail sliding system that we had developed for another project. And we just grafted the piece that they had created, the cylindrical cup that would go over the dowel. We created it to the actual sliding component using their Play-Doh designs to show us how it's supposed to go together. And all of a sudden we had this another one of those epiphanies where, those kindergarten students were playing a really important role in this. They were both the source of the problem. They were the testers. They were the ones who were going to give the feedback on what was breaking and what was not breaking. But we also realized for those fifth graders to have this really authentic design problem-solving solution, if we were going to try to have them go start to finish, it would be a failure. But having them develop, different aspects of the final solution where they actually had a part to play, and really important part to play in the thing that finally worked, they had as real an experience with solving problems as a student who would have gone from start to finish.
So you developed over time, and improved the method of solving those problems.
Yeah.
And so when you started this initiative and you started accepting, I suppose, if that's the right word, problems from the community, you started with a way of doing it where it was more monolithic in a way. Now you've got a lot more iteration. You take a lot more, your context is wider so that you can use alternative materials, see what works, what doesn't work, involve more people during the process. Sounds like a rapid development and iterative process.
Yeah, that's exactly right. We realized, because we're a pre-kindergarten to eighth grade school, if our model was going to be problem to final professional solution at the end, we were only going to be able to involve a handful of students in that. And we were doing that work. We had our whole sixth grade doing that seniors design project. So we had, that's 50 students doing it. But what we realized is if we were going to involve our younger students, we needed to have them involved at very strategic points in that design process where they could not just, sort of a perfunctory role, but an actual really important integral role. And then those kids, because they're involved in that and they see the full scope, then when they age and they become older, they're already fully aware of that full design process and they know the roles that they played in the past. We're clearly looking for them to be able to do that start to finish as well. So, yeah.
Yeah, it's amazing.
Thanks.
Just be mindful of the time. We just hit the 1 hour mark.
And I'm just getting started.
No, it's just time is flying. But we still have a couple of good ones here. I was looking at some of the articles that you've written, you've got linked on your website, and one of them is titled Sowing the Seeds of Empathy with Technology. And I don't remember seeing this combination of words before together, like empathy and technology. Could you take a few minutes to tell us about what you mean really by that, how technology and empathy actually work together?
Yeah, so this is the really interesting part of the work that we've really been bashing away at for a few years. So, we usually think of technology as this very kind of antiseptic, very unemotional approach to solving a problem. And in fact, what we're finding is the complete opposite, because these new generations of technology, and I'm really speaking primarily about 3D printing here, but we could be talking about, coding, we could be talking about gamification, we could be talking about creating apps, we could be talking about creating solutions with Arduinos. Marcus, that's where maybe we can have this conversation after the podcast is over. But for example, with 3D printing, for a student to be able to create a solution that works, they have to understand not only the problem itself, but they have to understand the poster of the problem, the person that created the problem. And when all of a sudden I had students creating devices for my son Max, even though my school administrators were concerned that I was just going to turn him loose to a bunch of eighth graders, and I was very careful, and I wanted to make sure that his physical health and emotional health were the prime concerns there. And so when we started that, it became really important for me to introduce my son to this group of eighth grade students and to spend time with him and to see him as a person and to provide them with opportunities to ask him questions about what he liked to do and what were his limitations and what sorts of things could he use that they might be able to design. And all of a sudden, I realized, like, in order for them to create a device or a product that's going to work, they need to understand him really well, and they need to be able to put themselves in his shoes. And that work continues today. When those students are looking for athletic equipment or a prosthetic piece of athletic equipment or a prosthetic piece of musical equipment, we always encourage them to have a conversation with Max, to put themselves in his shoes, to think of the school from his perspective. And that idea of pushing middle school students to think of their community through somebody else's eyes, that's powerful work right there. We do the same thing with the seniors as well. Right. You know, if our students are going to design a 3D printed assistive device for a senior, we're going to demand that they spend a good couple of months creating a relationship, both so that they can understand not only the problem, but also the person who posed the problem, but so that they also have a relationship built where when they need feedback, when they're almost there, the prototype is done and they've tried a few iterations, and now comes the tough work where a 80-year-old senior has to tell a 14-year-old boy that what he has created isn't quite good enough yet. You need to have a strong relationship there for that to work. And so we spend a lot of time developing friendship and relationships between the kids and the seniors, so that the kids can view the solutions through the eyes of the senior, but also so they can then leverage that wisdom and experience to help them make their, not just a sort of an almost working solution. We're looking for, professional grade solutions. And so they need that feedback. So, and in fact, this is one piece where I really feel like we've just scratched the surface. Is I think all of these new generations of technology where kids can create these high professional solutions, like, they all require kids to think hard about who they're designing with and for. So I think we found a new way to teach empathy here. So
you want to have an authentic relationship between the designer and the final user especially of a prosthetic, because it's a very private object, isn't it? So you really need to have an authentic relation between the two.
Well, empathy. Empathy is the big one.
Yeah. One of the things I learned from D-Lab, even though that was 7 years ago, like, it still daily informs my work, is it is really easy for somebody to design a solution for somebody who a problem that somebody has on the opposite side of the world. That's because you don't necessarily have to see the daily use of it, putting it into use. Oh, it worked okay, but then it broke. Oh, it worked okay, but then it started to chafe my wrist. So one thing that D-Lab does is their basic motto has nothing to do with just delivering the solution. Their motto all has to do with implementation over long periods of time. And the field of international aid is littered with people who their hearts were in the right place and they had a great idea, and an implementation, a solution was implemented, and nobody stuck around for a couple of years to see if it worked. One of the first projects that I did with D-Lab was we did this efficient cook stove, biomass cook stove project, where we had kids in Rwanda, Uganda, Brazil, and United States all building these efficient cook stoves to try to improve the efficiency, to use less fuel. And I learned through that most stove projects, a year after the actual real stove projects that people are using to cook their meals, those projects are often, they're completely abandoned after a year, just because one must understand the culture and the type of cooking and gender issues around roles in the house. Like, there's so many factors that can lead to the success or failure of a stove project. And unless you're there for the long haul, and unless you've taken a lot of time to try to figure out the people with whom and for whom you're designing, it's going to be a failure. So
it goes far beyond the engineering aspect. Then there's a lot of interpersonal skills that are involved. There's social engineering, if that word is correct, but it's not just engineering. And,
it's design.
It's design, which design is an art.
It's to a large extent. Design is not art. You're talking to the guy who's masters of design science. But it's quite interesting to hear all these words that you traditionally associate with UX, user experience, and design, and actually seeing them being applied in the classroom.
In your training as a design Did you touch onto those? I'm not saying you personally, but did your curriculum include those interpersonal skills with the end users, spending time with them over long periods of time?
Well, I was inside. I was inside the University of Sydney. They had the KCDC, which is like the key center for learning. Was it design and cognition? Mm-hmm. So there was a lot of thought being put into how other people perceive and think about the world and how they interact with the world of, like, literally cognition. So, yes, to answer your question.
Thank you. So there you go, Rich. So it seems like you reached these conclusions and this process that seems to be like a formal thing of training for designers these days.
I certainly didn't mean to send the message that we had figured this out independent of it. There were some amazing organizations. If anybody knows Stanford D School, they just do incredible work in just the field of human-centered design. And they have a great interviewing for empathy protocol that they encourage their makers to use and their designers to use. And IDEO is another great organizer. They're a company, but they do a lot of now education pieces, and that human-centered design is right at the center of what they do. So just try to take work that they do. And, I think the thing is, a lot of times educators would do this as sort of third parties to it. I think that the key that for me was bringing my son into it. And that was certainly a game changer just in the way that I viewed my own, relationship with my students and relationship with my practice. And all of a sudden that idea that I'd probably been aware of in theory or in the abstract, when it was my own son, he was 3 years old when we built that first prosthetic, like to really have to think, not only from my own point of view, but also from the point of view of my kids. I wanted to make sure that they were understanding him well before we went ahead and launched into this.
Which was quite amazing because I was just thinking, people looking at this probably think it's, a STEM, sciencey, technology kind of thing, but these are key skills that are used in business as well. So great.
Good business.
Yeah, great. Yeah. If you think about like the, not hacking news, what is it? Y Combinator. They have whole lectures on how to do human-centered design around products. So it's very much a business skill as well.
Yeah, absolutely. Yeah.
Great podcast to listen to. Yeah. Rich, we should move into rapid fire questions.
Yeah, sorry, we're running out of time.
Because there's a couple of really quick things that we want to get out of you that I think are very valuable for our listeners. For example, Marcus.
Oh, so who has been the most influential in shaping the way that you teach?
Yeah.
Dead or alive, could be fictional or a real person.
Yeah, so I would my first thought would be to sort of talk about some of the teachers that I had when I was a kid. Certainly like excellent teachers as well as just abysmal teachers who helped me see that there was untapped potential for education to empower kids. So those teachers will remain nameless at the moment, but I would have to say, so Amy Smith is the woman, she created D-Lab. When I reached out to her and with that email about saying that I was going to Rwanda and, it would be interesting to hear what's out there.
MIT.
Yeah. When the next day when I got an email back from her and her team, just a 8th grade science teacher, and she was wanting to meet with me to talk through this idea like that changed my life right there. And Amy and her team at D-Lab have been huge supporters of my work and have just been really like not only helping with making connections but also, making suggestions and also allowing me to kind of refine some of the approaches that I do. So I'd put her top. And if anybody out there is interested in this work, check her out. She has an amazing story as well, and just a real thought leader in that field. So.
Well, we are going to provide a link to Amy Smith and the D-Lab at MIT in the show notes. So just go there and you'll be able to just click on it. Now, I know that you work with a lot of technology, especially since there's Tinkercad. Are there any other applications? There could be, say, design applications, could be applications that you use to work with the students and monitor projects and document projects that you would recommend other teachers to look at?
Yeah, so I'm really thoroughly immersed in Tinkercad and Fusion 360. Those are the two design tools that we use with our kids. And I would not, I'm actually a biologist by training. I would not consider myself to be a a real technophile, somebody who, I don't code. I studied some coding when I was a kid, but have not used it since I graduated from university all those decades ago. And so right now I'm involved, that problem bank idea that I shared with you, the Ultimaker, that's the 3D printer company, asked if I would consider putting together a global problem bank idea where we have a number of different schools do that. They create a problem bank, and then we connect our students through the problems that they're solving and use that as a vehicle for the kids to get some social understanding there. We're like 1 month into that. That's been an exciting thing. And we try to get our kids to connect through very, very simple tech platforms. So emailing, just Weebly websites, Google Docs. Yeah, that's just a simple website creation tool. And just what I've realized, in fact, when I used to do these global collaborations, we used to do a lot of Skyping, and what we found was just the gains, there was diminishing returns. The Skyping with kids around the world is just the potential for those calls to drop, and kids tend to be not quite as resilient as we are in terms of like disappointment when that happens. And so we try to stay away from really high tech video conferences, and we try to use as much as possible just error-free collaboration tools. And really, in terms of my tech, there's a couple of other things. There's a really cool app out there called Clone. That's Qlone. They're a company that has created an app that allows an iPad to be used as a 3D scanner. Oh. And that's been really exciting just to, because scanners up to this point have not been either very effective or very cheap. And this is really the first time that we've seen some high quality scans coming from a really cheap app that allows us to scan. I also use another app with really young kids called Morphe. Morphe is a 3D design app that's just come on the scene in the last year or so. Some of the geometric designing with it is tough for young kids to do, but they have this really cool feature where you can draw with your finger on the iPad screen and then turns it into a SVG, and then you can extrude that and create a 3D print. And that's kind of cool when all of a sudden you have like a first grader that can actually write with their finger or create a prototype with their finger. And then, that whole thing of having somebody else then do the actual designing.
Right.
Yeah, so those are my main.
Yeah, awesome. Thank you. That's great. When you look those up, advice?
Would you have any advice that you give educators who are just starting out?
Yeah.
I've asked this question before. You know that.
Yeah.
You said so well.
When your administrator says, "Oh, that sounds really risky, and I don't know if we really should go in that," take that with a grain of salt. Now, I'm not saying like that. Every beginning teacher should just launch forward with every wacky, crazy idea that comes in their head. But if you have an idea that feels right to you, and I don't know, I always use the test of what would I have thought when I was a kid? Like how would this have resonated with me? And I don't know. I just thought like if I was a kid and my teacher had said to me like, "Oh, my son could use a prosthetic. Would you help me?" Not I have it all figured out and I want you to build a version of it. It's like if my teacher had come to me and said like, "I really want to try to solve this problem and I need you to help me do it." Like that would have absolutely just floated my boat, as we say here in the United States.
Absolutely.
So, and just to sort of put things through that filter, like what would you have wanted when you were a kid? And, and I certainly, I was being a little facetious there, not, administrators do great work. But you have to sometimes, this work always doesn't fit into that nice tidy box of, 8:30 to 4:00 in the afternoon and broken up into different disciplines. And, sometimes you're going to have to do things that are a little bit, like that thing of when the kids asked if they could come in on the weekends to build this thing, like all of a sudden I'm just, oh my God, like I'm now coming in on Saturdays with my kids. But imagine that, you had a group of 8th graders who wanted to spend a Saturday with their teacher in a lab, like, for a science teacher, what thing can be asked for? So, I don't know if that answered your question. Yeah.
Actually, I think this is great advice. So, thank you for that. I was just thinking as you were talking, the kind of projects that other guests on our podcast have, who were telling us about. Like, there was one guest who set up a whole parallel blockchain-based economy in his school in Melbourne. Imagine asking your principal for permission to do that. I'd like to set up a new economy so students can trade with electronic funds and trade with the sort of world. But and now, also a floating currency with the dollar.
But they pretty much own the school now, given their digital currencies.
They're paying the teacher salaries.
Yeah, pretty much.
And I know about other schools where they say, let's send a sensor array or a robot to Mars, and they're working with NASA to implement an experiment that will travel to Mars. So nothing really is impossible these days.
No, it's not. And as I sort of alluded, this new generation of tech is just allowing kids to do things that even 10 years ago would have been unthinkable. And now I think the exciting thing is like what's going to come from that. Once we see that given the right tools and the right instruction and the right opportunities to experiment and do that iterative process, like kids can create things that really work. Like where else can we use that? And it doesn't just have to be tech. It can be, mid-tech or low or even no tech. And yeah, we're in a new world that is really challenging schools to think about how to deal with kids and kids' ideas and kids' work.
Yeah. So teachers are change makers, right? Think of yourself as a change maker. Change will happen with you or without you, so might as well be with you.
Yeah, that is a perfect way to put it. And I've used that same analogy that those eighth graders, they're going to want to see what happens in their community. Why not have that be a positive experience rather than exactly as you said, like that could go horribly in some crazy directions. So. And
to wrap this up, I'm just going to make reference to the 2016 student Gallup poll that found that 42% of students in grades 5 to 12 want to make a positive change to the world.
It's a great way to wrap things up.
Yeah. Thank you, Rich. So we're going to have your email address, obviously, in our show notes. Is there any other way or means of contact that you'd like people to use with you?
That creating Changemakers email, that'll work. People can also reach me at rlehrer, that's RLEHRER, at BIE.org. That's my address through the Buck Institute for Education. And if anybody wanted to get more information about the broader field of project-based learning, you could certainly contact me there.
Got Twitter?
Yep. So at Rich Lehrer 1 is my Twitter handle. And I have a website, Rich Lehrer, RICHLEHRER.weebly.com. And I just try to keep track of some of the things that are percolating up and the broader, kind of changemaker philosophies and ideas that kind of lie behind some of the work that I spoke about. So.
That's great. Rich, thank you again for your time. It was a pleasure. 1 hour and a half almost. That went really quickly. It was like a minute.
Yeah, you thought I was kidding when I said I could go 3 hours on this. I
believe you now.
We'll have to get you on again.
Yep, to be continued.
Thanks a lot to both of you. I really appreciated the conversation. First of all, appreciated the interest in the work. That's amazing that you found your way to my work, and that was an awesome conversation. And I appreciate the time and the interest and the great questions. So thanks a lot.
Our pleasure. Have a good day. That's all for this episode. The notes for this episode that include links to many of the resources mentioned and information on how to get in touch with Rich are available on our website, texplore.com/pay/Stemiverse. Each episode comes with its own page on the Tech Explorations website and a goldmine of information in the notes. This Stemiverse podcast episode was produced by Tech Explorations. Do you have any questions or suggestions? Would you like to nominate a friend or colleague to be our guest? Please email us at pa@texplore.com. Subscribe to us on iTunes by searching for the name of our podcast, Stemiverse. That's STEMIVERSE. Thanks for listening, and we'll see you again next time.